Hello viewers, today we are going to start a series on metamorphic petrology. In this series, I will cover metamorphism and metamorphic processes, type of metamorphism, factor responsible for metamorphism, metamorphic grade, phases, zone, structures, textures, type of metamorphism, regional and contact metamorphism, phases, different type of phases based on low pressure, medium to high pressure and high pressure phases, and also the comparison of all the phases, particularly in regional as well as thermal metamorphism. Now let us start the metamorphism and metamorphic process. Prior to this, we have to understand what is the metamorphic rock and what are the basic difference between metamorphic and sedimentary rock and igneous rocks. Igneous rock is a primary rock and mainly formed by the crystallization of magma. They may be intrusive or extrusive types. Similarly, if these igneous rocks are weathered, transported and deposited somewhere in geosynclinal basin, then due to different processes acting during sedimentary rock formations, later on these sediments change into sedimentary rocks. Further, if igneous rocks or sedimentary rocks suffered by pressure and temperature, then they are changed into metamorphic rocks. Particularly, the metamorphic rocks are formed by the metamorphic processes in which the pressure, temperature are main factors, and for this the pre-existing rocks may be or sedimentary or igneous. Now let us see about the metamorphic processes and metamorphism. Normally, the metamorphic rocks are found in the core of the orogenic belt, particularly the area which are suffered, they are mainly the sedimentary rocks like shell, greyback, etc., or argillaceous, arenaceous rocks, and also the associated igneous rocks. They may get affected by pressure, temperature, and later on change into metamorphic rocks. Particularly in this change, that must be a solid state. Now let us see what is the word of metamorphism and from where it is derived. The word metamorphism comes from the Greek word metamorphosis, meaning to change or alter form. As the name applies, metamorphic petrology is the concern with transformation that take place in rock. The distinction between metamorphic petrology and igneous petrology is that the former is restricted to change that take place in the solid state, whereas igneous petrology is concerned with the evolution of the rock that were at one time liquid or at least partially molten. Now see, what are the changes particularly in metamorphic rocks? If suppose we will see the comparison in pre-existing rock as well as in metamorphic rocks, there must be mineralogical change, there must be a structural change, along with isochemical change. If suppose we will see 2-3 things is important, particularly the diagenesis and weathering process must be excluded from metamorphism. If suppose we'll compare igneous rock or sedimentary rock, which ultimately change into metamorphic rocks, then there must be certain new set of mineral formations, particularly during metamorphism. Now look at on the screen and see the definition of metamorphism. Metamorphism is the process of mineralogical and structural changes of rocks in the solid state in response to physical and chemical condition which differ from the condition prevailing during the formation of the parent rocks. However, the changes occurring within the domain of weathering and diagenesis are commonly excluded. Normally, the igneous rocks are formed at very high temperatures, particularly right from 650 up to 1200 degrees centigrade. If suppose we'll see the sedimentary rock formations process, normally the sediments transported and deposited somewhere in geosynclinal basin. Later on, the compactness, lithifications, and diagenesis occur, and normally the sediment change into sedimentary rocks. Particularly, the diagenesis process occur below 200 degrees centigrade. Normally, in diagenesis, no new set of minerals forms, only recrystallization of minerals. As compared to diagenesis and metamorphism, when temperature more than 200 degrees centigrade, then diagenesis merge into metamorphism particularly, and in metamorphism, a new set of minerals form with side by side. There must be structural change in rock which are differ from the pre-existing rocks. Say for examples, if suppose we'll take the structure point of view, like any dike rocks which are metamorphosed, we can see both textures, particularly igneous as well as metamorphic. Particularly in metamorphic point of view, there must be some sort of new mineral forms, maybe hornblende or garnet. Then on the basis of that, we can say the formation of new minerals, and particularly the metamorphism occur first in gravex or in basic igneous rocks. Normally, they are prone to weathering and metamorphisms. So these are the factors, particularly how the sedimentary or igneous rocks change into metamorphism with the effect of pressure and temperature, and normally there must be a mineralogical change, there must be a structural change as compared to pre-existing rocks. Particularly, the metamorphism start always above 200 degrees centigrade. Now see the type of metamorphism. If suppose we divide on the basis of local and regional scales, then on that basis we can divide the metamorphism into two types. One is your local metamorphism and other is your regional metamorphism. Particularly in local metamorphism, that must be in local scale, and in regional, that occupy 1,000 of square kilometers. If suppose we will see the local metamorphism, 2-3 processes are important here, particularly the cataclastic metamorphism or dynamic metamorphism, as well as the thermal metamorphism. Particularly, if suppose we will see, and on the basis of factor responsible for the metamorphism, we can divide the metamorphism into 3 important types. One is your thermal metamorphism, in which the heat is an important factor. Another is your dynamic metamorphism, in which pressure is an important factor. And third is your dynamothermal metamorphism, in which the pressure and temperature both are important factors. Now just take the first factors, that is your thermal metamorphism. Particularly in this factor, temperature is an important factor during change of any rock. Now let us see any intrusive body, if intruded in a country rocks, then normally around the intrusive rocks there must be some sort of areoles or zones developed. And from intrusive body towards outer zones, the heat energy is transmitted, and normally if suppose you will move from intrusive body towards the outer zones or areoles, the temperature normally decrease. And mineralogical changes right from immediate contact up to outer part. So normally in thermal metamorphism, heat is an important factor and pressure is very low. And if suppose we see the different metamorphic phases, so particularly during thermal metamorphism, 4 important phases are formed. These are Albite epidote Hornfels phases, Hornblende Hornfels phases, Paradoxine Hornfels phases, and Sanidenite phases. Particularly, Sanidenite phases normally occur at the immediate vicinity of intrusive rocks, and Albite epidote Hornfels phases normally occur at the outer fringe. Now let us take the second important factors, that is your dynamic metamorphism. Particularly in dynamic metamorphism, pressure is an important factor. Now let us see what are the changes when the pressure is only important factors or pressure only act on a rock mass. There is 2-3 important things. One is your cataclastic metamorphism or dynamic metamorphism, and second is your burial metamorphism. Now let us see the burial metamorphism. Particularly if suppose we will see the geosynclinal basins. Say for example, if depth is your 25,000 to up to 30,000 feet, so normally the stress pressure is very high, or in other words we can say the load pressure is very high, and normally there are no directional pressure. That is why particularly in dynamic metamorphism, normally there is no structural change. Only new sort of minerals form, particularly in zeolite phases. If suppose these 2 factors are important when only the dynamic metamorphism is there. One case is your burial, another is your cataclastic. If suppose we'll see and take the third important things where the pressure as well as temperature both are important, and this metamorphism is known as dynamothermal metamorphism. Here normally pressure as well as directional pressure as well as temperature both are acting. And normally in orogenic belts, the regional metamorphic rocks are formed where we can see the structural changes like slate change into phyllite, phyllite change into schist, and later on schist change into gneiss. We can see how the structural change as well as mineralogical change in case of peltic rocks or in basic rocks or even in ultra basic rocks. If suppose we will see the basic rocks, normally we can see there are mineralogical change, how the low pressure phases as well as high pressure phases are formed. Geological setting is a quite commonly used as a classification scheme because the geological context is often quite apparent, and there is a genetic relationship between the metamorphic type and the agent of metamorphism. These are four general categories: contact, shock, cataclastic, and regional metamorphism. If suppose on the basis of geological setting, if you will take the contact metamorphism, now let us see how the contact metamorphism occur and what are the changes particularly during contact metamorphism. If suppose we'll classify on the basis of local and regional, we know already the local metamorphism, it means is normally occur on a local scales. So we can put the contact metamorphism under local metamorphism also. Particularly in contact metamorphism, there must be an intrusive body. Now let us see the three important cases. If suppose the intrusive body is a granite or syenite or gabbro. Three important igneous rocks with a different temperatures. In the case of granite, normally temperature varies from 650 degrees centigrade up to nearly 800 degrees centigrade. In case of syenite rock, it's normally very around 900 degrees centigrade. In case of gabbroic rock, it's occur nearly 1200 degrees centigrade. Now let us see the case particularly in contact metamorphism. If suppose intrusive body is a three different types, so we can see how the temperature change particularly in country rocks. Now look at on the screen and see the sketches particularly for the contact metamorphism. In case of granitic rock, we can see the thermal areoles will be narrow as compared to gabbroic rocks where the temperature is nearly 1200 degrees centigrade. So these are the important factors, particularly how the thermal areoles or zones are developed. Now look at on the screen and see the width of the intrusive body. Say for example, nearly 0.5 kilometer, 1 kilometer, 1.5 kilometers. If these are the variations particularly in intrusive bodies, what will be the effect particularly on metamorphism of thermal category? Suppose we'll see the third case, particularly at what depth the intrusive body. Normally, we can assume because the geothermal gradient is always vary. In case of continent, is normally vary with 25 degrees centigrade per kilometer to 35 degrees centigrade per kilometer. In this case, the horn-felsic textures are formed, particularly the grains are recrystallize, melt and recrystallize. And normally there is a lack of cystosity. As compared to regional metamorphism and thermal metamorphism or contact metamorphism, there is a lack in cystosity as well as grain size. Particularly in contact metamorphism, grains are finer and recrystallize without any orientations. And normally the shock metamorphism occur due to the impact of meteorites, and particularly in meteorites impact, the high pressure effect, and normally cosites are formed. And if anywhere the cosite is there, we can say this must be a high pressure metamorphism, normally due to impact of meteorites. Now see, let us the another type of metamorphism, that is your regional metamorphism. And particularly, if suppose we will see the regional metamorphism, in regional metamorphism, three categories important. One is your dynamic metamorphism and dynamothermal metamorphism, and third case is your ocean ridge metamorphism. If suppose we'll see the dynamic metamorphism, particularly in dynamic metamorphism, the cataclastic textures, cataclastic metamorphism occur, and these indicates the shear planes or fault planes. Normally, during cataclastic metamorphism, the rock are crushed and recrystallized. So we can see the fabric change right from outer part towards the shear planes. Close to shear planes, normally the myelonites form where the fabric is almost crushed and fracture develops, which also responsible to percolate the waters, and normally these are the weak planes where, if suppose we'll see the case of Himalayan, normally the landslides occur along these zones. If suppose we'll see the second important case is your burial metamorphism, where the pressure is an important factors. And normally in this case, there is no structural change, only due to high load pressures. Normally, the new set of minerals form without any structural deformations. And very important case is your geolite as well as glaucophil lawsonite phases, where in those two cases, pressure is very high, more than 4 kilobar up to 8 kilobar. And we can see the important sedimentary minerals also occur in these phases. And third important factor, particularly for metamorphism, is in regional, that is your dynamothermal metamorphism. As we already discussed, if suppose we'll see the case of ocean ridge metamorphism, prior to 60s and 70s, it was presumed that ocean floor is normally ultramafic or basic igneous rocks. But after the deep sea drilling, Mayashiro, he reported the metamorphic rocks of basic composition along the ridges, particularly where always the thermal imprints is there. Whatever basic rocks or ultra basic rocks is changed into metamorphic rocks. These metamorphic rocks are normally greenstone or amphibolites and equivalent to your oceanic basalts. Now let us see the last type of classification based on plate tectonic and see how the different metamorphic phases occur with different metamorphic plates, like plate interior, divergent plate margin, transfer plate margin, and convergent plate margins. And see the important phases occur on 4 different plate margins. Now it's time to conclude particularly the metamorphism and metamorphic classification based on different factors responsible. In my next lectures, we will discuss about the factor responsible for the metamorphism, like temperature, pressure, fluid, composition, along with zone, phases of metamorphism and grade of metamorphism. Now it's time to say goodbye to all of you. Thank you very much.